Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from economic load dispatch. The name of a topic is economic dispatch including generator limits, but still here we are neglecting losses. Now in addition to the constraint that the total generation should be equal to a total demand. Already we have seen whatever will be a total demand, that much amount of a total generation should be there. This is the one constraint which is called as equality constraint. In addition to that, the power output of each generator must satisfy inequality constraint. So please remember, this particular constraint is called as what? It is called as equality constraint. This will be your equality constraint. And each generator should satisfy one kind of inequality constraint also. So what is that? PG minimum to PG maximum. So I can write it as this will be equal to, why it is called as inequality? Because it is not always equal, it might be lesser or greater. So it is called as inequality constraint. So if I take it here I, if I take it here I, then this I will be equal to what? 1, 2 up to n number of generators. Now the procedure for economic dispatch is the same as earlier. That is, the plants are operated with the equal incremental fuel cost till their limits are not violated. As soon as the plant output reaches its limit, that is maximum or a minimum, its output is fixed at that point and maintained at that level. Other plants are operated at an equal incremental cost, then the generations are fixed. Means what? Let me give you a simple example. Suppose I have two generators. This is my generator 1 and this will be my generator 2. This is G2, this is G1. Now the G1 has the limits, it might be suppose in between 20 to 100, and G2 has a limit, let's say Pg2 will be equal to what? It will be equal to, suppose let's say 50 to 300. Means what? Below 20 megawatt generator G1 is not support, and above 100 megawatt it is not going to produce power, and below 50 megawatt this generator G2 will not produce a power, and above 300 megawatt it will not produce a power. Suppose by calculation, suppose if I have a demand, let's say demand will be equal to suppose 100 megawatt. Let me write it here as 100 megawatt. Suppose by calculation, if I got answer as Pg1 will be equal to 40 megawatt and Pg2 will be equal to 60 megawatt, then I can say that these two conditions are not violated, because for a generator 1 it is possible to produce 40 megawatt as it is in between 20 to 100. But for generator 2, again it is in between 50 to 300, so it is possible. This is the one case if we got this answer. But if I by calculation, after calculation, if I got answer like this, Pg1 equal to 10 megawatt and Pg2 will be equal to 90 megawatt, because we know that total load is 100 megawatt. Now for generator G2 it's okay, 90 megawatt lies between 50 to 300, so we can take it. But what about generator G1? Its power produces 10 megawatt, but this generator G1 will produce minimum of 20 megawatt only, below which it will not go. So in that case what we have to do, we have to consider that instead of producing 10 megawatt, your Pg1 is going to produce a minimum power which is 20 megawatt, and for fulfilling this demand, now the new value of a Pg2 will be what? It will be 80 megawatt. So if we have these conditions, these constraints have been given in a numerical, and if you got this kind of answer, it's okay, it's of no any harm, because it will lie within whatever limits we have given. But if we by calculation, if we got this kind of answer, then what you have to write there? 10 megawatt is not possible to produce by Pg1 because its lower limit is 20 megawatt. So therefore let us consider that it will produce a 20 megawatt. So after producing 20 megawatt, for fulfilling a 100 megawatt, what amount of power will be produced by Pg2? It will be 100 minus 20, which will be equal to 80 megawatt. This will be the one case. Now suppose, let's say the same example, suppose let's say my demand is I'll take it as 200 suppose. Okay, now my by calculation, suppose if I get Pg1 equal to 100 and Pg2 equal to 100, it's okay because both will lie here. Pg1, it is in between 20 to 100, a less than or equal to term is there, so it's okay. And Pg2, it lies between 50 to 300, so it's of no any issue, we can take it. But by calculation, suppose if I got like this, Pg1 equal to 150 megawatt and let's say Pg2 will be equal to 150 megawatt. Now again there is a problem. Now your generator 1 is going to produce 150 megawatt, but its limit is 100 megawatt only. So it is not going to produce a power beyond 100 megawatt. So what we have to consider here, now I need to consider that my generator 1 will produce only 100 megawatt, only 100 megawatt, and the remaining power, because this is the maximum power which will be produced by generator G1, and the remaining power which will be produced will be PD minus Pg1, which will be produced by generator G2. So it will be what? 200, because this is a demand, minus 100, so it will be 100 megawatt. So if you got the answer while solving a numerical like this, it's okay. But these limits have been given to you, and if you got this kind of answer, then what you have to do? Instead of writing this 150 megawatt, you have to write here a note. As generator G1 is capable of producing a maximum power of 100 megawatt only, so it is not possible to produce 150 megawatt. So let us consider that Pg1 will produce a power of 100 megawatt. So what will be the remaining power produced by a remaining generator? It will be total demand minus this, so we will get it as 100 megawatt. So please remember, your dCi upon dPgi will be equal to lambda. And what is the condition? If your Pg is less than or equal to Pg maximum I, and this will be your Pg minimum, please remember. So then your dCi upon dPgi, it will be less than or equal to lambda. It will be less than or equal to lambda. When it is possible? When Pgi will be equal to Pg maximum I. Pgi will be equal to what? Pg maximum I. Please see it carefully. This is the case. So here we have written. So Pgi will be equal to Pg maximum I. And your dCi upon dPgi, it will be greater than or equal to lambda. When it is possible? Whenever Pgi will be equal to Pgi minimum. So please keep in mind, if in the numerical we have such kind of inequality constraints have been given, then how to solve the numerical? This is the topic of economic dispatch, including generator limits. These are the generator limits, inequality constraints we are including, but still we are neglecting the power loss, that is PL. Thanks for watching this video. If you have any doubt, please feel free to ask the questions. Thank you once again.